Alright, so this is the same type of question we've been working with, going from f prime back to f, but it's in a multiple choice format. So it's very important that you understand the connection between f prime, which is this graph, and the graph of f. That x-intercepts on f prime, which I've indicated here in pink, x-intercepts on f prime mean either relative extrema or drags on f. And relative extrema, which I've indicated here in the with the orange dot, mean inflection points on f. And that's the correspondence between these two special points on f prime and how they turn into special points on f. So the question asking us here is, at what value of x am I going to have a relative max? So which of these points do you need to focus on? The pink one or the orange one? Well, if you're looking for relative extrema, you're looking for x-intercepts. So you're focusing on these 2 points right here. So we look at them more carefully. We make a sign chart for f prime. Positive, negative, 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 negative. And we look for a change in sign. Over here we have a change in sign from positive to negative. So that means that we have a relative extrema, more specifically a relative max, which is what they were asking us to find. But I'd like to go through these other 2 special x's. I'd like to take a look at this one. Here you go from negative to 0 to negative. Because there's no sign change, there's no sign change here. See that? Negative, 0, negative. Because there's no sign change, there's no relative extrema. But it's still a special point, which I have informally called it a drag. So then my question to you is, what's going on at x equals negative 1? Well, at x equals negative 1, f prime is a relative extrema. That means that f has a what? You're right, an inflection point. So these special points on f prime are also special things going on f that you should now at this point be able to just recognize by looking at them, which is kind of the purpose of this question.